Hi, this is Jason with MathTutorDVD.com, and in this section we're going to continue talking about fractions, and specifically we're going to talk about how to convert between mixed fractions and improper fractions. Don't forget that they basically describe the same thing. It's just that when you have a mixed fraction, maybe you have 2.5 pizzas. Well, you have so many whole number of pizzas plus some fractional part. An improper fraction is describing the same thing, and we talked about that in the last section. We talked about that when you have 3/2 of something, you have 3 pieces, but you only cut your pizza into 2 pieces, so that must mean that you grabbed all of that pizza plus part of another pizza, so you have more than one pizza when you have an improper fraction, basically. So how do you convert them? Let's say you have the mixed fraction 2 2/3, and you want to convert that to improper. The easiest way to teach you how to do this stuff is to do it completely by examples. So what you do is you take the bottom number, multiply it by the number in front, so 2 times 3 is 6, and then you add to it the numerator, which is 2, and then for the denominator you keep the same one, which is 3. So 6 plus 2 is 8/3. This is the fraction. That's the improper fraction. That's absolutely equivalent to this. If I take pizza and divide it into 3 pieces and try to take 8 pieces, then I must be taking more than one whole pizza, and that's what this is telling me. I've taken 2 whole pizzas plus 2/3 of another one. These two fractions are exactly the same. Some teachers, they don't like you to keep it in terms of improper fractions, so you need to learn how to convert back and forth. So that's what we're doing. All right, what if we have 3 1/3 pizzas? How do you convert that? Well, you always start at the bottom. 3 times 3 is 9, plus the 1 from here, over, you keep the bottom number. Don't do anything to the bottom number. So what you get is 10/3. And that's the answer. What if you have -4 2/5? How do you convert that? -4 2/5. What you do is you go ahead and keep your negative sign out front, because this is just a fraction that happens to be negative. And then you work with the numbers by themselves. 5 times 4 is 20, plus the 2 from here, and then for the bottom you just keep the 5. 2 plus 20 is 22, and don't forget it's a negative, so you have a negative sign on here, over 5. So -22/5. That's the answer. So when you have a negative out there, just let it hang out there by itself. Let's say you have 7 3/4. Start at the bottom. 7 times 4 is 28, plus the top, which is 3, divided by the bottom, which is 4. 28 plus 3 is 31/4, and that's the improper fraction. That's equivalent. What if you have 5 7/3? 5 7/3. Same exact process. This is not going to change. 5 times 3 is 15, plus 7 divided by 3. 15 plus 7 is 22 divided by 3. And that's the improper fraction. That's totally equivalent to that fraction. What if you have -10 2/3? Well, you have a negative sign here, so just leave it out front and then work with the numbers. 10 times 3 is 30, plus the 2 from here, divided by the 3 from down here. So you'll have -32/3. -32/3, and that is the fraction that's completely equivalent to this guy right here. So we've learned how to take a mixed fraction and convert it into an improper fraction. A lot of times you'll be asked to do that on a test, especially a lot of teachers. If you get in a mixed number, sometimes they'll ask you to go ahead and convert it for them. Now, we need to know how to go in the reverse. When you have a improper fraction, how do you go back and get this mixed fraction? So let's do it by working examples. It's easier just to show you rather than to talk about it. Let's say I have 4/3. That's my improper fraction. Sorry, the top is bigger. Now remember what I said. Fraction is nothing more than division, really. So what you're doing is 4 divided by 3. So the way to tackle this is to ask yourself, what is 4 divided by 3? How many times can 3 go into 4? Well, it can only go one time. It can only go one time. But if I go one time, then I'm going to have 1 times 3 is 3, and I'm going to have 1 left over to make up. In other words, the remainder is going to be 1. So I write the remainder as 1, and I write it out of 3. Now, I'll say that again, because that's a lot of steps there. You got to figure out how many times can 3 go into 4. It can go one time. But if it only goes in once, then I've got 4 items and I've only divided in 3. So what's the difference between those two? 4 minus 3 is 1, which I write as my remainder 1, but I've got to write my remainder as 1 out of 3. So what I'm basically saying is 3 can go into 4 1 1/3 times. It can fit one whole time plus another third. It can't quite go in 2 times. It can fit one whole time plus just a tiny bit more, 1/3 more time. Let's do a few more. I think you'll get the hang of this. First, let's go off and do 5 out of 1. Well, you can just do the division there and figure out that 5 divided by 1 is 5. So there's nothing else to do there. It goes a whole number of times. There's no remainder, so I just stop. What if I have 8 out of 3 pieces of pizza? How many times can 3 go into 8? Well, it can go 2 times because 2 times 3 is 6. If I try to make it go 3 times 3 is 9. That's too many times. But 2 times 3 is 6. 8 minus 6, getting the remainder, 8 minus the 6 that goes in there is 2, but I have to write it out of 3, which is my original fraction. So 3 can go into this guy 2 whole times plus a little bit more, 2/3 more. It can't quite fit 3 times. It can fit 2 2/3 times. Okay? So what if I have 8 out of 8? So you look and say, well, what's 8 divided by 8? I'm just doing division here. 8 divided by 8 is 1. There's no remainder, so there's no other fraction to put there with it. What if I have negative 10 divided by 3? Well, don't worry about the negative sign. Just put the negative sign out in front. How many times can 3 go into 10? Well, 3 times 3 is 9. 3 times 4 is 12. That's too many, so it can only go 3 whole times. 3 times 3 is 9. 10 minus the 9 gives me a remainder of 1 out of the 3. I have to always write it out of the 3, so negative 3 1/3. What about 15 out of 2, or 15 seconds? So you can say that. How many times can 2 go into here? Well, 2 times 6 is 12. 2 times 7 is 14. 2 times 8 is 16, but that's too many because I'm only going for 15. So it can go 7 whole times. 2 times 7 is 14. 15 minus 14 gives me a remainder of 1, but I have to write it out of my original fraction, so 1/2. So it goes 7 whole times plus another half. It can't quite fit 8 times. It can go 7 1/2 times. Now what if I have 16 over 4? Then what I try to do is I say, okay, divide these guys. 16 divided by 4, that's an even number. That's 4. There's no remainder, so there's nothing else to write. Final one, negative 20 over 11. Keep your negative sign along for the ride. 20 over 11. How many times can 11 go in? Well, 11 times 1 is 11. 11 times 2 is 22. That's too many, so it can only go one time. 11 times 1 is 11, so I have to subtract 20 minus 11. That gives me 9. That's a remainder, and you write it out of 11. So 1 and 9/11. So the negative sign is here because the original fraction is negative, but on the whole, it can go in 1 whole time plus 9/11 of another time. So basically what you're doing is you're dividing. You're finding out how many times it can go in. You write that as the first number in the mixed fraction, and then you got to figure out what the remainder is, how much is left over, in other words, and then you write that remainder out of the original denominator, because that is sort of like the fractional part that it can continue going in without totally going into there. So that's what you would get there. And some of these times you get whole number, and that's just because the division happens to be pure with no remainder left over at all. All right, so this is a section on converting mixed numbers to improper fractions, and improper fractions back to mixed numbers. And we've done that, giving you some examples. What I want to do now is switch gears a little bit and talk about simplifying an expression, a fraction, basically. So we're going to be doing fraction simplification here for just a second. We're going to make it a little more interesting. Let's give you something a little more challenging. What if we had 6x over 3? Let's say this is a fraction. You remember, x can be a number. It can be anything. So this is just a fraction with a number on top and a number on bottom. But I have to keep x by itself there separately because I don't know what x is. So what you're basically going to try to do is take these numbers and divide them. You're going to first try to divide them or simplify the fraction as if the x were not even here. And then we'll talk about how to deal with the x in a second. So if this were the only fraction here, you would take 6 divided by 3 and you would get 2. So you write 2. That part is the same. Now the x, there's nothing really going on. There's no x in the bottom or anything, so x just stays along for the ride. So when you simplify this, you're going to get 2x, and that's the answer. Okay? Now what if you have 12x squared divided by 4? Well, you do the same thing. You kind of pretend there's no x there at all, and you look at 12 over 4, and you figure out, well, 12 divided by 4 is 3, so that's what you would write if that's all that were there. But now you look at the x squared. What you're really going to be doing is looking in the top and the bottom to see if there's any x's common there, but there aren't any. So this x squared on the top just continues to go along for the ride. You don't really change anything. Now here's when we're going to start doing a little bit more with the x's. What if you have 18x cubed times y over 3x? First thing you do is you cover these things up and just pretend you have numbers. So 18 divided by 3. Well, that's easy. That's going to be 6. So you write that. That's what you would do if that's all you had. The next thing you do is you start looking at things that are common to the top and the bottom. Now remember, x cubed is x times x times x, right? And so you have 3 x's on the top, kind of multiplied in a row, and you only have 1 on the bottom. So really, one of those x's in the top is going to sort of cancel with the one on the bottom. You're going to be left with sort of an x squared there. It's going to cancel out. So when you write the answer, when you do this division, you're going to get x squared times y. The y sticks around because he's not canceling with anything. Basically in algebra, and this is a super important concept, so don't overlook what I'm doing here. This is stuff you're going to use all the time in algebra. When you have a fraction with letters on the top, variables, and variables on the bottom, basically what you do is you try to cancel them out. You try to see what is common to the top and to the bottom. And whatever is common in terms of variables, they disappear. And that's because if I give you the fraction, let's say, just sort of an aside here, what if I give you the fraction 2 times 3 divided by 5 times 3, right? How would you do that? Well, you could multiply 2 times 3 and get 6 over 15. You could do that, sure. But I'm telling you that if you really think about it, because they're multiplied in the top and they're multiplied in the bottom, what you really have is 3 divided by 3 here, which is 1. So they basically disappear. So what you're going to get is 2/5. And if you did it the long way, 2 times 3 would give you 6, 5 times 3 would give you 15. But you can simplify this fraction by dividing the top by 3, and you can divide the bottom by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. That's what you get here. So that's what I'm trying to say. When you have something common to the top and the bottom, in this case it was a 3, they don't really disappear. It's just that they divide out and you just get 1. So they sort of disappear. So that's what it is when you're dealing with numbers. When you come back to algebra, anytime there's an x in the top and an x in the bottom, that x goes away. So this x disappears, but remember this x cubed was like 3 x's, x times x times x. So only one of the x's disappears, and I replace the exponent with a 2. And that's why it's here. The y hangs on because there's no y down here to cancel. If I had a y here to cancel, they would both disappear, just like the 3's. So let's go and do some more. We're going to do so many of these it should be clear. 16 a squared times b over a times b. How would you write that? Well, the 16, there's nothing on the bottom, so you just keep 16 like this. And then you start looking at your variables. Well, you have 1a down here that can cancel with this squared, because this is like a times a up here, so you're only going to have 1a left over. This b cancels with this b because it's common to the top and to the bottom. So at the end, you're going to have 16a is the answer. Don't go on until you understand. B cancels with b just like it does up here. Divides out, in other words, is what's happening. This a squared is like a times a. One of those a's up here cancels with one of those a's down here, leaving you with 1a in the top. And this is what I want you to do in your paper. When you're doing cancellations, I want you to strike right through an exponent, strike right through a variable if that's what you need to do. Actually, I don't want you to decide if you need to do it. That's the way you should do it. This is the way I do my work. I strike right through it really lightly. Okay, 12 times a times b cubed over 8 times a times b. How would you simplify that? Well, first you look at the numbers and figure out how you would simplify that. And, you could divide the top and the bottom both by 4. So if I did that, if I did 12 divided by 4, I would get 3. And if I did 8 divided by 4, I would get 2. So that takes care of the numbers. Now as far as the letters, I have an A on the bottom and an A on the top that divide out, basically give me 1, so they disappear. One of these B's goes away, and I change this exponent of 3 to a 2, so I'm going to have B squared left over. Because there was 3 B's multiplied here, one of them was canceled, that left me with 2 B's left over. So 3B squared over 2. 3B squared over 2. Okay, let's just do a couple more. We'll do a couple more just to get everybody warm and fuzzy with this. What if we have 20 times C cubed times D squared over 15C squared times D? How would we simplify that? Well, first you look at the numbers. What can you divide into the top and bottom? Well, I can divide 5 into there, and I can divide 5 into there. So 5 times 4 is 20. 5 going into here is going to give me 3, so I can handle the numbers that way. When I look at the variables, I have C squared here, which is C times C. I have C cubed up here, so this 2 of the C's are going to go away, and I'm going to get rid of the 3. I'm only going to have 1 C left over in the top, because 2 canceled with 2 of these, it left me 1 left over. One of these D's is going to cancel with one of those D's, and so I'm going to be left with a D on top. So 4CD over 3. Well, we can have something like 24m squared over 36mn. So how do we handle this? Well, we'll just pick the first number that comes to mind. Well, I can do 6. I can divide top and bottom by 6. So 24 divided by 6 will be 4. 36 divided by 6 would be 6. And then as far as the letters go, one of these m's cancels with that one of those, leaving me with 1 m on the top. N doesn't cancel with anything, so he stays on the bottom. Now I notice that my numbers aren't fully simplified. I can actually divide again by 2, right? So 4 divided by 2 is 2, and 6 divided by 2 is 3. And that would be the fully simplified answer. Okay, what if I had 12y times z squared over 18y squared times z? First, work with the numbers. I can divide by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. And then I work with my letters. So this y cancels with one of those y's, leaving me 1 y in the bottom. And this z cancels with one of these z's, leaving me with 1 z in the top. So 2z over 3y. And the final problem is 21xy over 14y squared. So I start looking at the numbers and I see right away I can divide by 7. So 21 divided by 7 is 3. 14 divided by 7 is 2. And I start looking at cancellations. Well, x doesn't cancel with anything, so x stays on the top. This y can cancel with one of these two y's, leaving me with the y on the bottom. So 3x over 2y. So this lesson was a very important lesson. We learned how to take an improper fraction and convert it to a mixed fraction. We've learned how to take a mixed fraction, convert it to an improper fraction. And we've also learned the extremely important skill of how to simplify an algebraic fraction that has letters, in other words variables, and numbers. The numbers you deal with, just like you always do, divide top and bottom by something. And then for the letters, you basically just look for cancellations, because in a fraction, anytime something is in the top and in the bottom at the same time, they basically divide out to give you 1. And that's a crucial skill, because a lot of times you'll have a complicated looking algebraic expression and you'll start having to cancel terms and get rid of things and simplify it. Now I want you to step back and look at what you've accomplished. Maybe you had some fear of algebra when you started. Maybe you weren't sure what to do or how hard it would be or if it was going to be hard at all. If you understand this stuff, which it's not hard to understand, you just have to get the hang of it, then you're going to be able to tackle anything algebra throws at you. Because look what you're doing. You're taking these complicated looking algebra expressions and simplifying them. That is a super, super important skill. I promise you, as you learn these things, practice your work, get good at these skills, all of the future topics are just going to be very pleasant, actually, and easy to understand. You'll get confidence and do very, very well.